Okay, let's continue on to discuss vectors. So scalars, which are vectors with only one object, and vectors are very commonly used to manipulate, summarize, and sort data using R, and it's a very important skill to master. But for some reason, some people find it a bit confusing. We're here to help you clear that confusion. We'll go through a few examples here using vectors to illustrate some important concepts. Perhaps the simplest type of data structure is the vector in R. Vectors that have a single value, that means it has a length of only one, are called scalars, as I said. And vectors that have more than one value are just called vectors, and they can have any length that you want, or any length of data contains. Vectors can contain numbers, characters, factors, or logical objects. We'll discuss all these later on, but one key thing to remember is that all elements inside a vector must be of the same class. You cannot mix numbers, characters, logicals, and so on. You'll get a data error. So that's a key concept to remember when dealing with vectors. To extract a vector, also known sometimes as indexing or subscripting, one or more values, sometimes known as elements, from a vector, we use the square bracket notation. This is a new thing that we're learning, a new notation. The general approach is to name the object you wish to extract from, then a set of square brackets with an index of the element you wish to extract contained within the square brackets. This index can be a position or the result of a logical test. Okay, let's create a simple vector to use as examples. I'll copy this example, go to RStudio, and we'll use the combine command, the C command or C function, to give it a list of objects, and we're gonna separate each object with a comma. So 2, 3, 1, 6, 4, 3, 3, 7. We'll evaluate this, and we will see that we get the my vector or our object created. Okay, so that's pretty nice. We get a vector. Let's talk about beginning to extract elements based on their position, and we can simply write the position inside the square brackets. For example, to extract the third value of the vector we just created, myvec, if I issue myvec square bracket 3, okay, so I'll go back, evaluate this, and you're going to see that it returns the third value in our vector. So 2, 3, and 1. That's the third position in our vector. If you want to store the values in another object, you can just assign, using the smaller than or equal sign, that positional vector value into a new object called val3. So if I now evaluate this in the terminal or console, you'll see that we have a new object equals val, which is named val3, which has the value of 1. Okay, very simple. Note that positional index starting at 1 in R is very different than other programming languages. In other programming languages like Python, the positional index starts at 0. This is something that you need to keep reminding yourself if you also have learned Python. We can also extract more than one value by using the C command or C function. This is a very useful function that you've seen before. It can be used to create vectors, but it can also be used within the square brackets. So for example, in this command, we can extract the first, the fifth, the sixth, and the eighth element of the myvec object. So if we now copy this and we go back and we create myvec2 and assign it myvec only for positions 1, 5, 6, and 8, you will see that I get a new vector with only the data in those specific positions. Very simple. We can also extract a range of values. If we have a lot of values and we want to extract ranges, instead of writing them all down, we can use the new notation, which is the 2 dots. To extract the values from the third to the eighth element, you can use myvec 3 to 8. Okay, sometimes it's called colon in English, but you use that to assign a notation that will tell R to range between 3 and 8. So if we assign this, we're going to get all the values of the far between the third and the eighth position. Let's talk about a logical index. Another very useful example to extract data from a vector is to use a logical expression as an index. For example, to extract all the elements within a value greater than 4 in the vector myvec, we can say myvec, open bracket, myvec greater than 4, and it's very clear what's going to happen. The logical expression myvec greater than 4 will tell R to only extract those elements that satisfy this logical condition. So if we do this, it's going to go and only return back values that are greater than 4 in the myvec vector. How does this actually work? If we look at the output of just the logical expression without the square brackets, you can see that R returns a vector containing either true or false. This corresponds to whether the logical condition is satisfied for each element. In this case, only the fourth and eighth element that you've seen returns a true as their value is greater than 4. So what R is actually doing under the hood is equivalent to going to my vector and creating a list with true and falses, and only those elements in that list that are true will be extracted. In addition to the smaller and greater operator, you can also use composite operators to increase the complexity of your expressions. For example, the expression for greater or equal to is greater equal. To test whether a value is equal to the value we need to use, you can use a double equal symbol, equal equal. The reason is, as you've probably guessed, is that we use the equal sign for assignment. So if we really want to use a mathematical equal, we need to use a double equal. So that's the reason. We can also use a not equal, which is question mark equal. The question mark, which we'll see a lot used throughout this course, means not. So you can look at all these examples of greater than 4 and equals to, smaller than, smaller and equal to 4, not equals 4, and so on. And all of these can be used as logical indexes. We can also combine multiple logical expressions using Boolean expressions. In R, the AND symbol means and the pipe symbol means or. For example, to extract values in myvec which are less than 6 and greater than 6, we can use this complex example. So we're saying to R, create a new vector called value 26 and assign from my vector only values in myvec that are smaller than 6 and values in myvec that are greater than 2. So what's going to happen is it's going to create a new vector and only include values that fall between those two parameters. You can extract values in myvec that are greater than 6 or less than 3 in a very similar example. So it's exactly like the example before, but it's not and, it's or. So let's take a look at this. You can see the difference. When we evaluate this, it's going to only leave values that are greater than 6 or smaller than 3. Okay? Let's talk about replacing elements in a vector. We can change the values of some elements in a vector using our square bracket notation in a combination with assignment operators. For example, to replace the fourth value of our myvec object from 6 to 500, we can use the notation to indicate the position we want to replace and assign the value of 500 to that position. Very, very handy. So if we go to myvec, and if we evaluate it now, before we assign this, you'll see that in the fourth position, we have the number 6. We can now assign to the fourth position the number 500. And now we can see that we've changed the number from 6 to 500, and it's been assigned to that vector position. We can also replace more than one value, or even replace values based on a logical expression. For example, we can change the positions 6 and 7 to be 100. We can also replace elements that are less than or equal to 4 with 1,000 by using this notation. In myvec, values that are below 4 will now be 1,000. Let's look at this example. We'll evaluate myvec to see how it looks now. And now we'll assign 1,000. Every position that was smaller than 4 got the 1,000 value. Very handy. In addition to extracting particular elements from a vector, we can also order the values contained in the vector. To sort the values from lowest to highest, we can use a new command called sort. A new function, a new command. If we sort the myvector vector, we can go back and recreate it so we have smaller numbers to work with. We'll now see that the vector is ascending. It starts with a low number and goes all the way to the highest number. To reverse the sort from highest to lowest, we can either include decreasing equals true as an argument when using the sort function. So if I go myvector, comma, and give it an argument, okay, it will sort decreasing. So we'll sort the first vector using the sort function and the reverse sorting using the reverse function. Okay? There's another example of nesting one function inside another function. So you can say reverse sort myvector, and that will nest one function sort within another function called reverse. While sorting a single vector is fun, perhaps a more useful task would be to sort one vector according to the values of another vector. This is very powerful. To do this, we would use the order function in combination with the notation square bracket that we've already learned. To demonstrate this, let's create a vector called height, containing the height of 5 different people, and another vector called p.names, containing the names of these people. So, for example, here Joanna is 180 centimeters and Charlotte is 155 centimeters. Let's copy this and create it in our script. I'll create the first vector, again using the concatenation command or combine command, the C command for short, assigning it whether it's smaller than or equals to p.names, and assign these values. Notice that as opposed to the first vector that we create, which is height, which we created, here because I'm using a character variable, not numeric. Remember, you cannot mix numeric and character variable or alphanumeric variables. I have to use quotes to make R understand that this is indeed a character variable. So if I create this variable and evaluate it, you'll see that we have now two vectors. One is called p.name, which is a character variable indeed, and one that is called height, which is a numeric variable. Okay. Our goal here is to order the people in p.names in ascending order based on their height. The first thing that we'll use is the order function. And we'll use it with height variable to create a vector called height order. So let's do this. Okay, so let's go back to the script and order the vector height. We have the vector height, right? If we order this and create a new variable, height order, you'll see that we got the order of 2, 3, 4, 1, and 5. Okay? The first value, 2, okay? Remember, we ignored the positional indicator on the left. This is just telling us where this presented vector starts at should be read as the smallest value of height in the second element of the height vector. If we check this by looking at the height vector above, you can see that element 2 has a value of 155, which is indeed the smallest value. The second smallest value in height is the third element of height, which when we check is 160 centimeters, and so on. The largest value of height is element 5, which is 181 centimeters. Okay? Now that we have a vector of the positional indices of heights in ascending order, height order, that's the vector we created, we can extract these values from our p-names vector in this order. Let's take a look. We can use p-names, notational brackets, height order, and create a new vector called names ord. And now the names are going to be sorted by their ascending height. You're probably thinking, when am I going to use this? Well, imagine if you have a data set which contains 2 columns of data. You want to sort in each column. If you just use the sort command to sort each column separately, the values of each column will become uncoupled from each other. By using the order on one column, a vector of positional indices, remember we're talking about positional indices, is created of the values of the column in the ascending order. This vector can be used on the second column as the index of elements, which will return a vector of values based on the first column. One of the great things about R functions is that most of them are vectorized. This means that the function will operate on all elements of a vector without needing to apply the function on each element separately. For example, to multiply each element of a vector by 5, we simply can do this. Create a new vector, and then just multiply that vector by 5. Let's look at this nice example. When I evaluate my vector, create a new vector, again, we'll see the numbers. If I multiply this, it will go to each position and multiply each object by 5. Very neat. We can also do the same to add elements of 2 or more vectors. So I can add one vector to another, I can multiply one vector to another. Any mathematical operation that you can think of can be done to the vectors. However, you must be careful when using vectorization with vectors of different length, as R will quietly recycle the elements in the shorter vector rather than throw an error.